Kubernetes is an open source platform designed to run containerized applications at scale. It can automate deployments, provide auto-scaling, and includes many other features. Originally, it was developed by Google and is now maintained by Cloud Native Computing Foundation. Now, let's go over some key features of Kubernetes. First of all, Kubernetes is primarily a container orchestration platform. You can think of it as an abstraction layer on top of the hardware or virtual servers. When you install Kubernetes, you no longer need to worry about where to run your container. Kubernetes collects all the information about underlying servers, like available CPU and memory. Then it decides where to run your container based on its specific requirements. If you have many compute resources, Kubernetes can efficiently utilize every server you have. It also manages the lifecycle of the containers. Kubernetes starts the container, checks if it's healthy, and can automatically scale the number of containers to meet demand if needed. Second, Kubernetes automates deployment and scaling of containerized applications. It uses high-level objects like deployment and stateful set to manage rollout of new versions automatically. Kubernetes has a built-in horizontal pod autoscaler. This feature can automatically scale your applications based on CPU or memory usage. With third-party tools like Flagger, you can easily implement blue-green or canary deployments with minimal effort. Additionally, Kubernetes monitors the health of your applications. It can automatically restart or replace containers that fail or become unresponsive. Next, Kubernetes provides built-in load balancing to distribute network traffic to containers. Inside the cluster, you can use a regular service of type cluster IP. It uses round robin to send requests to each container behind that service. Or you can use a service of type load balancer or ingress to expose your application to the internet. Kubernetes also supports service discovery. This feature is primarily based on pod labels, allowing containers to find and communicate with each other inside the cluster. Then we have self-healing capabilities. This means if a container fails or becomes unresponsive, Kubernetes will restart it or replace it with another one. This is common for legacy applications if they run long enough. The same applies to the underlying servers. If a Kubernetes node fails, it will reschedule all the applications from the failed node to other healthy nodes. This is especially useful in the cloud. For example, you may have a noisy neighbor on the hardware server where you run your virtual machine, or you could be using cheap spot instances that can be taken away by the cloud provider at any time. Next, Kubernetes uses declarative configuration. This means you define the desired state of your application, such as how many replicas you want to run. Kubernetes then runs reconciliation loop. It checks the desired state, compares it with the actual state, and takes necessary actions if there is a deviation. This approach is very different from the imperative approach, where you define the commands to run in order to achieve the state you want. Kubernetes is very good at running stateless applications because they are much easier to scale. However, it also supports storage, allowing you to run stateful databases like Postgres. Due to the nature of Kubernetes, if underlying node goes down, Kubernetes will reschedule your database on another node, and you may lose all your data. To solve this, Kubernetes supports storage. You can attach a volume to your container. If the node goes down, Kubernetes will not only reschedule your database to another node, but also detach and attach the volume to the new node. This way, you're not going to lose your data. There are many storage options available, such as network file systems. For high performance, you can use a local static provisioner with fast local SSD disks. This option is particularly useful with Apache Kafka, as its bottleneck is the speed at which it can write and read data from the disk. And finally, we have secret and configuration management. You can use Kubernetes secrets to store sensitive data such as usernames, passwords, and application tokens. Additionally, you can decouple application source code from environment-specific variables by using config map. For example, in staging environment, you can connect to the staging database, while in production you can connect to the production database. You can manage other properties in the same way as well. Now, why would you want to use Kubernetes? Well, first of all, scalability. You still need to build and optimize your containers. For example, use multi-stage builds to reduce the size of the image and follow other best practices. If you do this, Kubernetes can quickly download your images and scale your application to meet demand. It can also reduce the number of instances when the demand goes down. Kubernetes can scale your application horizontally by increasing the number of instances it runs, or vertically by adding more CPU and memory to your applications. Next, Kubernetes is very portable and platform agnostic. You can run it on premises, in public clouds, or even in hybrid setups where part of your containers run on premises and the other part in the cloud. This allows you to quickly scale by adding more virtual machines in the cloud to your Kubernetes cluster while still maintaining cost-effective deployments on premises. Also, Kubernetes is very flexible. It was built to support many different plugins and extensions. For example, you can use CRI, Container Runtime Interface, and use different runtimes such as Docker, Containerd, and others. Additionally, you can use different virtual networking plugins such as Flannel, Calico, and others. They provide different capabilities such as network policies. Or you can use native cloud networking, so your pods and services will allocate VPC native IP addresses and will be routable inside your virtual private cloud. And of course, since Kubernetes won the container orchestration war between different platforms, it has a huge community and rich ecosystem. For example, you can use Argo CD or Flux CD to follow GitOps best practices. You can use Nginx Ingress to share a single load balancer and expose your services outside of your cluster, and it supports custom resources, which makes it easier to extend. For example, projects like Crossplane use Kubernetes internal reconciliation loop to manage cloud infrastructure and compete with Terraform. And before we dive into the Kubernetes internals, let's briefly talk about Kubernetes history. Kubernetes originated from Google project called Borg, which was a large-scale internal container management system. Google released Kubernetes as open source project in 2014. And in 2015, Kubernetes was donated to Cloud Native Computing Foundation, which is a part of Linux Foundation, to ensure its continued growth and open governance. Now, Kubernetes has become de facto standard for container orchestration, providing a robust and flexible platform to deploy, manage, and scale applications efficiently. Nowadays, almost all companies use Kubernetes in some form. It can be serverless like EKS Fargate or self-hosted Kubernetes cluster on premises.